Hello there, my name is Denzel Diwata and I will discuss about the Global Positioning System or the GPS. The Global Positioning System or the GPS is a US-owned utility that provides users with positioning, navigation, and timing services. GPS is a radio navigation tool that has the unique ability to provide an exact location at any second, which can be used for accurate navigation. This system consists of three segments: the space segment, which consists of the satellites, the control segment, which consists of stations and ground antennas, and the user segment, which are the end users. The US Air Force develops, maintains, and operates the space and control segments. First, we go on to the space segment. The GPS space segment consists of a constellation of satellites transmitting radio signals to users. The United States is committed to maintaining the availability of at least 24 operational GPS satellites, 95% of the time. To ensure this commitment, the Air Force has been flying 31 operational GPS satellites for the past few years. GPS satellites fly in medium Earth orbit or MEO at an altitude of approximately 20,200 kilometers. Each satellite circles the Earth twice a day. The Air Force normally flies more than 24 GPS satellites to maintain coverage whenever the baseline satellites are serviced or decommissioned. The extra satellites may increase GPS performance but are not considered part of the core constellation. Let's now go on to the control segment. Here you can see the different facilities comprising the control segment all around the globe. The GPS control segment consists of a global network of ground facilities that track the GPS satellites, monitor their transmissions, perform analysis, and send commands and data to the constellation. The current operational control segment includes a master control station, an alternate master control station, 11 command and control antennas, and 16 monitoring sites. Next segment is the user segment. We are already familiar with the use of GPS in navigation, especially in navigation apps like Waze. Like the internet, GPS is an essential element of the global information infrastructure. The free, open, and dependable nature of GPS has led to the development of hundreds of applications affecting every aspect of modern life. GPS technology is now in everything from cell phones and wristwatches to bulldozers, shipping containers, and ATMs. GPS boosts productivity across a wide swath of the economy, to including farming, construction, mining, surveying, package delivery, and logistical supply chain management. Major communication networks, banking systems, financial markets, and power grids depend heavily on GPS for precise time synchronization. Some wireless services cannot operate without it. In aviation, GPS is also used. It is almost the same as our navigation apps, except for more advanced details for the use of air navigation. GPS is used in air navigation for several reasons. It gives continuous, reliable, and accurate positioning information for all phases of flight on a global basis, freely available to all. It is safe, flexible, and fuel-efficient routing for airspace service providers and airspace users. It gives way to potential decommissioning and reduction of expensive ground-based navigation facilities, systems, and services. It also can reduce aircraft delays due to increased capacity made possible through reduced separation minimums and more efficient in-air traffic management, particularly during inclement weather. In marine navigation, GPS is also used with the same advantages as the use of GPS for aviation. It allows access to fast and accurate position, course, and speed information, saving navigators time and fuel through more efficient routing. It improves precision and efficiency of buoy positioning, sweeping, and dredging operations. It also enhances efficiency and economy for container management in port facilities. So how does the GPS work? Here is an overview of the complete process. Now, let us look at each of the processes. First, GPS satellites broadcast radio signals providing their locations, status, and precise time, which we can call T1, from onboard atomic clocks. Second, the GPS radio signals travel through space at the speed of light, which we can call c, more than 299,792 kilometers per second. Third, a GPS device receives the radio signals, noting their exact time of arrival, which we can call T2, and uses these to calculate its distance from each satellite in view. And lastly, once a GPS device knows its distance from at least 4 satellites, it can use geometry to determine its location on Earth in 3 dimensions. To calculate its distance from a satellite, a GPS device applies this formula to the satellite signal. Distance is equals rate multiplied by time, where rate is c and time is how long the signal traveled through space. The signal's travel time is the difference between the time broadcast by the satellite, which is T1, and the time the signal is received, which is T2. Going back in determining its location on Earth in 3 dimensions, the GPS receiver needs 4 satellites in order to determine its own location. The mathematical principle behind this is trilateration. Looking at the 2-dimensional view, on the right side on the picture, you need at least 3 satellites to have a single intersection or to pinpoint a single location. The same concept applies in 3-dimensional space, but instead of circles, we use spheres. On the left side shows this. 3 satellites intersecting will show you 2 points, and the Earth will act as the 4th sphere to eliminate the point in space since the location we are finding is on Earth. An approximate position can be found with 3 satellites, but to improve accuracy and precise altitude, 4 or more are better. That is all. I hope you learned something new today, and thanks for watching.